Hey there, Algebra 2 students. Today we are starting a new chapter. We're going to start a unit on probability. And so when we start a new chapter, there's usually a lot of vocabulary. So we want to go over some of these new vocabulary words before we get into some practice problems. A probability experiment is an action or trial with varying results. And those results from a probability experiment are called outcomes. And an event is a collection of one or more outcomes. The sample space is the set of all possible outcomes. And the probability of an event is a measure of the likelihood or chance that the event will occur. It's always a number between 0 and 1, including 0 and 1, and it can be written as a fraction, a decimal, or a percent. And let's see, for the purpose of time, we're going to skip some other words and we're going to dig into some practice problems. But the probability of a complement is 1 minus the probability of the event A, right? So, let's see here. In questions 1 and 2, they ask you to find the number of possible outcomes in the sample space. So a stack of cards containing 13 clubs from a standard deck of cards. So there's only 13 cards in this new stack, right? And so you pick a card from the stack and you flip 2 coins, and they want to know all of the possible outcomes. Well, there's 13 cards and 2 coins. Each coin has a head or a tail, right? So there's 2 options for each of those. So 13 times 2 times 2 would be 52 outcomes. And they want you to list all possible outcomes. So you can see here I have 2 head, 2 head tails, 2 tails heads, 2 tail tail. And then I have continued that for if you draw a 3, a 4, a 5, 6, 7, 8, 9, 10, jack, queen, king, or an ace, right? So those are the cards followed by the first coin and then the second coin. And so there's 52 options. And I'm not going to read all of those right now, but you can see that that's what we're looking for when we ask for a sample space. Okay. The second one says you spin a spinner with the numbers 1 through 5 on it and you roll a die. Well, a die has 6 sides. So how many total outcomes are there? Well, there's the 1 through 5 times the 6, and that's 30. So, again, you'd have, if you spin a 1 and then roll a 1, spin a 1, roll a 2, spin a 1, roll a 3, spin a 1, roll a 4, spin 1, roll 5, spin 1, roll 6, and you do that for all of the different spins. And you have your 30 outcomes. Okay, it's extensive when you have a lot of options, right? Let's take a look at this one. When 2 tiles with numbers between 1 and 10 are chosen from 2 different bags, there are 100 possible outcomes. Find the probability that A, the sum of the 2 numbers is not 10, and B, the product of the numbers is greater than 10. So the sum of the numbers, so I started to make a chart here, and I started listing 1 through 10, didn't get all the way to 10. Came here, listed to 10 across, and I started writing in the sums, right? 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, etc. So here I can see, it's the sum of the 2 numbers is not 10, right? And so in the first row, you can see that there are 9 that are not equal to 10. in the second row, you can see that there are 9 sums that are not equal to 10. And you could continue that on down all the way through. You will have 9 in each row that are not adding up to 10. So that would add up to 90 over 100 or 90%, right? We always put the desired outcomes on top and the total outcomes on the bottom. So if there's 100 possible outcomes, that goes on the bottom, and the desired outcomes is 90. Part B says that the product of the numbers is greater than 10. So I made another chart, but this time I did it on a whiteboard, and I didn't even complete it. So I listed my numbers from 1 to 10 on the side and 1 to 10 across, and then I started filling it in with the products, right? So 1 times 1 is 1, and so on for the first row. 2 times 1 is 2, 2 times 2 is 4, etc. Okay, and I only went till I started to get to numbers above 10 because they're saying, okay, you want a product that's larger than 10. So with the third row, I did up to the 4 to 12. 4 times 3 is 12. 5 times 2 is 10. 5 times 3 is 15. 6 times 2 is 12. 7 times 2 is 14. And so then I started filling in with dots, and I got even tired of filling in the dots. So you might be able to see this. In the first row, there are 5 numbers. Actually, the first row, there are no numbers that multiply to larger than 10. In the second row, when you start multiplying by 2, there are 5 numbers that would have a product larger than 10, and then 7, followed by 8 and 8, and then there are 5 rows that have 9 products larger than 10, right? And so I multiplied those. And then I added them all up. There's 73 of them out of 100, so it's 73% have a product larger than 100. Nope, larger than 10, sorry. Okay, we've got a couple more problems, and then I'll turn you loose. So number 4 says, at a school dance, the parents sell pizza slices. The table shows the number of pizza slices that are available. A student chooses a slice at random. What is the probability that the student chooses thin crust with pepperoni? So we put the desired outcome on top. Thin crust pepperoni is 34 slices, right? But then on the bottom, if they're choosing at random, we need to put the total number of slices at the bottom, right? So 34 out of 90, because 34 plus 36 plus 8 plus 12 is 90. And you do that division and you get 37.8%, or 0.378. Or you can leave it as a fraction, 34 over 90, or simplify it to, 17 over 45. Lots of different ways to write the same probability. You see this next question. Find the probability that the polynomial x squared minus x minus c can be factored if c is a randomly chosen integer from 1 to 12. Okay, I had to write all of them out and see whether or not they could be factored. And the things that I'm considering when I factor them is, okay, what things multiply to -1? And can I get them to add to -1, right? And when I wrote out all of these polynomials, the only ones that would work are the -2, the -6, the -12. So there's 3 possibilities that work out of 12 of them, so that's 1/4 or 25%. Now, I want to talk briefly about this. If you throw a dart at the board, the dart is equally likely to hit any point inside of the square board. What is the probability that your dart lands in the smallest triangle? Well, I don't know what this 30 degrees is talking about. What what they are labeling there. So we didn't do this, but in theory, you should find the area of the triangle, right? And then you should divide by the total area of the board. Area of the triangle divided by the area of the board. That's it. And so there's this question: what is the probability your dart does not land anywhere in the circle? So if it's not landing in the circle, it's landing on the outside of the circle. So we can find that area by taking the area of the square, subtracting the area of the circle. And then we want to divide by the total area of the square again. So the area of the square, if they tell us the radius is 4, then the diameter is 8. And so for the square is 8 by 8, or 8 times 8. Right, so the square is 64. The area of the circle is pi r squared, or pi times 4 squared, which is 50.27. So do 64 minus 50.27, and you get 13.73. But you have to divide by the area of the square, which is 64, and you get 0.215, or 21.5%. All right, that is it for today for our introduction to probability. I hope you are well. We'll see you next time.